Good afternoon and welcome to the second Academy of Science STEMI lecture. My name is Pep Naidu and I'll serve as your program director this afternoon. Thank you and welcome to the Post-Industrial Society and the conversation around artificial intelligence. Professor Benjamin Rossman will lead us in shaping South Africa's AI future. First, some housekeeping rules. Question and answers. Do type in the Q&A box your question and we will respond at the end of the session, end of the lecture at the Q&A session. The proceedings will be recorded, including the presentation, and you will get a copy after the event. Do keep your microphone and videos muted and off and in the off mode, in general, and when required, you can communicate with us. To start, Dr. Melusi Twala will open on behalf of the Academy of Science. Dr. Twala, over to you. Thank you.
Thank you, Professor Naidu. Greetings to all our attendees. I'm Melusi Twala from the Academy of Science of South Africa. It is my great pleasure today to deliver opening remarks on behalf of the Academy of Science of South Africa. Science engagement is one of ASAF's core objectives, and this entails the promotion of science education, as well as the culture of scientific literacy in society. We do this commonly by convening various sectors to discuss topical issues. And often we call upon our experts and thought leaders to share evidence-informed perspective on a diversity of issues that affect society today. ASAF public lectures, such as this 2-year-old STEMI lecture, are amongst the prime platforms for evidence-informed dialogue that the Academy hosts. The ASAF STEMI lecture advances dialogue on issues that cross-cut science, technology, engineering, mathematics, as well as innovation. Artificial intelligence as a global megatrend cross-cuts many of interests of society as well as those of the academy. For instance, AI influences all of ASAF's focus areas currently, and these include service to society, digital transformation, future of society, as well as the nexus of food, water, land, energy, and climate change. It is therefore with excitement that we look forward to today's insights that will be shared by Professor Rossman on AI relevance to scientific discovery, service delivery, education, industry, as well as our daily lives. ASAF appreciates the STEMI Standing Committee for hosting this prime science engagement platform. We are also very, very grateful to Professor Rossman, our speaker today, for agreeing to share his insights and dedicating his time from his busy schedule to be with us today. Thank you, Program Director, for this opportunity, and back to you.
Thank you. Thank you, Melusi. Let me invite my colleague, Professor Marisa Rolnick, to join me in introducing the speaker. Prof, if you would come forward, over to you.
Good afternoon, everybody, and I hope you're all as excited about this talk as I am. I'd just like to give you a little bit of background about Professor Rossman. He's a professor in the School of Computer Science and Applied Mathematics at Wits University, where he leads the RAIL laboratory, also known as Robotics, Autonomous Intelligence and Learning. In 2024, he became the founding director of the MIND Institute, sorry about all the acronyms, Machine Intelligence and Neural Discovery at WITS, which focuses on the fundamental science of intelligence in machines, humans, and animals. He's also founder of the Deep Learning in Daba Machine Learning at Summer School, which aims to strengthen machine learning across Africa, and Lalapa AI, an organization building AI for Africans by Africans. In 2025, he was named one of the Time magazine's most influential people in AI and was made a fellow of the Canadian Institute for Advanced Research, CIFAR, another acronym, in the Learning and Machines Brains program. He's also named a National Geographic Explorer in 2024 and received a Google Faculty Research Award in Machine Learning in 2017. On a personal level, my first exposure to AI was from Professor Rosman. He probably doesn't know. I attended a talk by him at WITS on the 17th of February 2023, which he made very accessible at a time when very few people understood ChatGPT, explained in an accessible way how computer learning takes place, error correction, adding complexity, and what I remember most was how to create images. He spent considerable time dealing with the limitations and usefulness of AI, and then focused on us as university educators on how we deal with it in terms of student reactions and student learning. I'm looking very much forward to his talk.
Thank you, Marissa. Thank you, Marissa. Thank you. Professor Bosman, it's over to you. And he's going to deliver for us his talk on shaping intelligence, science, sovereignty, and South Africa's AI future. Over to you, Prof. Thank you.
Thank you so much. Can you see my slides?
Yes, confirmed. Thank you.
Wonderful. Great. Well, thank you so much, Asaf, for the great honor and the invitation to be here. This is really a huge honor. And thank you, everybody, for taking time out of your afternoon to be here with us to have this discussion. Yeah, so I want to talk today about, something I've been thinking about for quite a while and working towards. Now, I spend much of my time focused on very specific areas in artificial intelligence, specifically this area called reinforcement learning, which is about autonomous decision making. I spend a lot of time working on robotics and so on with my lab. But that's not what I want to talk about today. I want to talk about kind of a different lane of things, something that's, I think, started off as a bit of a kind of thoughts at the back of my mind a number of years ago, but over the years it's become a more and more pressing issue and something that's taking up more and more of my cognitive bandwidth. And so I thought this would be a great opportunity to talk about some of these questions, and that's really about where we're going with AI and what is our role and relationship to AI. Now, there's so many different aspects to this and so many different things to talk about. But I'm, for obvious reasons, going to look at kind of angles around science and sovereignty, particularly as South Africans. But of course, there's so many things to talk about here. So let's get into this, and I hope it's an interesting story. Now, I've been kind of working in and around AI for coming up on probably about 20 years now. And it's been interesting to watch this journey. And I don't know if many disciplines go through this in a kind of short space of time. But I remember early on in my career when people would ask me what I'm working in. And I would say artificial intelligence, because, I wasn't going to go into like the technical details and say exactly what my niche area was. I'd say I'm working in artificial intelligence. And then I'd keep getting these kinds of answers that say, whoa, so you believe in aliens? Now, that was kind of weird, I thought. I'd get other strange answers. One of the first talks that I gave, also back then, I remember talking about AI, quite a lot. I wasn't very good at giving talks back then. I kept saying AI, and then there's a gentleman at the back who was just shaking his head and eventually stood up and blurted out, "I'm sorry, I have no idea what you're talking about. Isn't AI artificial insemination?" So, this was kind of funny, particularly when we look at the modern times when you can go to your hairdresser and your hairdresser will very happily tell you about whatever's happening in AI these days. I think particularly since crypto is less exciting, this has become one of those hot topics. But, I talked about these kind of funny anecdotes, but, what this represents to me is kind of this sea change in really a short space of time. Like, in the order of about a decade, it's gone from this thing that's just associated with the craziest sci-fi down to something that everybody knows something about. And again, this is interesting, and this is, I think, quite unprecedented in science. Um, and there's a lot of things going on here. So the first and most kind of important core thing here is the competency of AI. Now, the field goes back to the 50s, and there's been, constant work chipping away at things for decades. I mean, that's not a long history of the field, but despite that, building on so many other fields as well, really the kinds of tasks people are interested in, our performance has been getting better. And there's so many results one can look at here. I've got a little bar here at the top. I'm not sure if it's blocking out the top of the thing. Hopefully not. Anyway, so you can look at a whole lot of different tasks, ranging from kind of the earliest one on this chart is on image classification. That's this blue line, this first blue line over here. And we've often measured performance, again, with AI being about intelligence. We measure performance on things humans are comfortable with. And going back 2012 and even before then, people were interested. A big task was, how well do we do on classifying images? And back in 2012, which was when there were some big breakthroughs happening, that's when deep learning was starting to become a thing. We're getting like 90% accuracy on tasks relative to kind of human performance. And then that's been improving over time. But subsequently, with the huge amount of excitement going on in this area, there have been all these other metrics that people have started caring about, going from reading comprehension, multitask and multilingual language understanding, PhD level science questions, visual reasoning, which means looking at an image and telling you what's going on in that, English language understanding, competition level mathematics. This is like Olympiads and so on. And multimodal understanding and reasoning. This means working with different sources of data, whether it's text or image or audio and so on. And kind of, if you look at this very kind of rough plot here, you can see kind of just upward trend on all of these metrics. Many of them were things that people could only start taking seriously in the last couple of years because we needed a whole lot of the baseline technologies to reach a certain level of maturity. But that kind of upwards trend is the first thing to notice, and pretty fast upwards trend. I mean, some of these things, if we look at like the math competition level mathematics, the light blue line, in 2021, it was like 10%, and now it's kind of superhuman. So we see this upward trend. And secondly, we see that things are kind of crossing the human baseline. So these tasks have been calibrated on this graph to be, compared to human level performance. And this is interesting. Again, if we look at kind of the speed of improvements, but secondly, we take all of this together and think about this as a general purpose basket of capabilities. Okay, so with all that going on, there's also kind of real world impact that comes somewhat downstream of that. Now, we're used to this in science. We do science and it kind of starts with more blue skies type science and ultimately ends up making some real world impact, some fields that's quicker than others. But we just look, for example, at the number of medical devices that were kind of AI powered that were approved by the FDA over the last couple decades. We can just see from kind of the 2010s, again, that's roughly when the kind of deep learning revolution started happening. We just see this explode, right? Now, this isn't necessarily saying that these things are useful. I mean, there should be some level of use if it was FDA approved, some level of not being harmful. But again, this is an interesting kind of explosion that we're seeing in what people are doing with this technology. Now, with all that's going on, and I don't need to tell you this, I mean, we see and hear about this every day in every forum, whether it's in our own disciplines or in our roles as educators or when we're looking in the public space. Like, we know there's a lot of excitement happening. But I argue this is, something we should call a disruption because it changes the way we see things and it changes business as usual. Now, here's something that I think is quite indicative of what's happening. Right, so this is a log graph showing for various large language models since 2019, how well they do on certain kinds of coding tasks. Now, the metric here is they gave them some software tasks with an idea of how long would it take to code that task. So this is all about coding. And if you give the thing the tool these challenges, like if it gets it right 50% of the time. So we start here on kind of the leftmost with GPT-2. So that was before the public moment. And it could code what, would take a human maybe 3 seconds to code, right? Which is hardly impressive. But as we move towards the right of this graph and we look at kind of the modern times, and we're looking up the exponential axis here, right? We're now at the point where these tools, again, in a space of like 5-6 years, are able to do coding tasks that take a human more than 10 hours to do. Okay, so this I think is a super interesting thing, because again, we often think about our AIs as these days being something we talk to, which in itself is quite an interesting revolution. But we give it an instruction and it goes thinking for a little bit. In fact, there's a joke now that if you've got a company and you've got software that you write, and you've got a loading screen that says loading at any point in your software, if you change it, instead of saying loading, it now says thinking, you can call yourself an AI company. But anyway, if we look at this kind of trend upwards, what this means is like the kind of thinking that it can do would be equivalent to 10 hours of human work. And this is in the code that it can generate. Now, code, as we'll speak about, kind of underpins a lot of our other technology, but we can also see how this kind of density of dots increases towards the right here, that there's just more and more happening in the space. And again, this is kind of showing exponential increase because this is the log graph. Now, if we can kind of project this, making predictions about the future is always hard, but, if you expect some level of continuation on this, right, we could easily expect that, in the next few months, we'll be at the point of these tools being able to do the equivalent of a few days worth of coding, what would have taken a human a few days, or weeks and so on. And, then you're comfortably in the realm of something that's at a par with our top software developers anywhere in the world. I think this is only the beginning. And there's a number of reasons for this, ranging from kind of what we've seen in the trends, ranging from if we look at the kind of clear stated aims of the field are to be able to replicate any human task at any level of proficiency, right? So the ambition is there. The kind of trajectories are there. And we've seen no reason why this should stop. There's interesting philosophical discussions we can have, but it's also hard to think if there's any kind of capabilities that we possess as humans that might not be possessable by this kind of technology. But when we look at what kind of things are happening now, I think a key indicator is that these tools are already way cheaper than they were a couple of years ago. In fact, recently there was a stat that the inference cost, which is kind of how long it takes for one of these large language models to kind of produce its output, fell about 300 times over an 18-month period, which is really outstanding, right? This is the kind of number we don't see kind of anywhere, right? But in addition to that, as I showed you, we've got longer task horizons. So instead of, going from your very short task, which might be, I don't know, we could ask Google a query and it gives us back a response. Now you could ask it to write you an essay or a good chunk of a grant proposal, or indeed, as I showed you, equivalent to 10 human hours worth of coding, right? So if you look at that kind of exponential curve, we've got that these task horizons double every approximately 7 months. We've then got this interesting trend where they're becoming more agentic. Now, there's a lot to say here. I'm not going to go too deeply into it, but the kind of trend everyone's excited about, or has been excited about over the last few years, has been around this generative AI, the ability to generate things. Agentic AI is kind of the newer thing. Some of us like to say we were working in this area before it became a buzzword and became an adjective. We were working with autonomous agents. But what this really refers to is versions of these kinds of tools that you can give them goals that they cannot just carry out in one step. They've typically got to do a whole sequence of things to be able to solve the problem, and sometimes even rely on different AIs to be able to help them solve that problem. A simple example might be you want help with some online marketing, and maybe your AI then has to come up with a strategy, and it invokes other AIs to help develop the content, help develop the image that will go with the thing, to actually post the thing online, and then have another agent that's monitoring for feedback and so on. So we're at the point where, we can easily kind of get these things to carry out tasks over like a half an hour to an hour kind of range. Then we're seeing the impacts of some of these tools. Famously, people have started giving Nobel Prizes to not quite the AIs, but the people involved in driving a lot of the AI development, and that's in non-AI fields, like the impact of AI in other fields, which we'll come back to in a couple of minutes. Then something that's pretty terrifying if you're in the academic space is we're sitting on the order of about 100 to 150 publications per day in the field, which again is a little obscene. But it shows you a couple of things. It shows you, one, the number of ideas coming out there. It shows you the number of people invested in this. And it shows that it really is this kind of global, really dynamic conversation that's going on. And finally, the kind of big engine behind this all is the investment. And we're looking at the moment, the estimates are well upwards of $250 billion annually going into the AI industry. And this is kind of across startups and corporates and so on. So you've got all these pieces here of kind of the task complexity getting significantly higher, the cost dropping significantly. We're seeing the impacts, and there's just so much going on kind of intellectually and financially in the space. And the problem is that these disruptive effects are compounding considerably faster than any of us can deal with, and like our institutions as well. I think if we stopped all AI research today, it would probably still take us years to come to terms with what's been developed over the last few years and figure out how to make the most of it and incorporate that best into our society. But what we're seeing here is we've still got this exponential growth. I don't know how long it will carry on for, but there's no reason to think this will stop anytime soon. And while it's continuing, this is just kind of compounding. So what I want to look at today is really three questions. One, where are we in the AI era? And I've started talking about that. We'll go into that a bit more. Two, where is this taking us, and particularly our science? And then what role should we be playing as Africans in shaping this future? And I'm going to divide this up into kind of three acts. The first, where we are, kind of the stakes and what's happening. Two, how we got here and where Africa is actually currently in this field. And finally, where we need to go next and where we're already making steps towards going next. And hopefully I'll make this case to you that this is something we really need to be kind of just charging ahead on, making sure that we're not just participating, but in the leadership seat of this technology. So let's talk a bit more about this AI, right? So we're not just talking about another wave of technology. A lot of people dismiss this as hype. I mean, people talk about it as another digital tool or a productivity upgrade or a software cycle or just some sort of vacuous trend that's going to go away when a bubble bursts. And I think that's missing the point of what this is at its core, right? This is a science that's kind of dedicated to understanding, replicating, and improving on human cognitive functioning, right? So everything we pride ourselves on as humans, in what we've built as a society, typically comes from our cognitive capabilities. And unlike every other technology in the past, this is something that kind of mirrors that and enhances that, but is also able to do things itself, right? It's this new layer of cognitive capability, right? Where we sit at the moment, I'm pretty sure many people, if not all, in this call at the moment, use AI in some way, shape, or form in their daily work, maybe in their personal lives. I do both a fair bit. And then when we look particularly at the kind of impact on our science and on our industry, it's really becoming an engine of invention, innovation, and discovery. And I'll go into this a little bit more. And I would argue it's becoming the new source of scientific and strategic power, which we have to really take seriously. So what makes this different specifically? And kind of, as I said, there's a couple elements to this. One is that it's kind of about cognition. It's about the things that we pride ourselves on as humans, the things that let us build, the software we're using to have this webinar today, or the clothes that we're wearing, or just everything we've got around us, like are products of our cognitive processes. And AI is really about that. And not just a single slice of that, that's really looking at the entire thing. That, like, it's got this mission to understand what our brains are about and to be able to kind of replicate this in silico. And kind of by definition, that means it has to be general purpose. And so this is why we see impacts over so many domains, because that's kind of almost written into the mission statement of what this technology is about. And that means there's lots of things it can do. It can perceive, right? Whether that's you typing in text, whether that's you giving it images or doing face detection or helping you navigate around difficult like traffic scenarios, or telling you that something's going on with your pulse from your smartwatch, right? All of these are kinds of perception, analogous to what we're doing as humans. Once it's able to perceive, it's able to predict, and we've used these technologies for many, many decades, going back to our, linear regressions and logistic regressions as kind of the building blocks. But, this is typically, again, where we make progress in the world is by being able to make predictions. When we build new scientific models, it's because we want to predict things. This is a capability just built into AI. We've seen the effects over the last few years of being able to generate, right? And that, to some extent, is kind of the absolute form of prediction. That means you've got a model of what text in some domain looks like, or what images look like, or what music looks like, right? Is being able to generate it. It's going that step further than being able to differentiate, but actually understanding something about the core principles. If it can do all these things, it can optimize, including, as we'll talk about later, optimize itself and improve itself, and kind of improve the process of improving itself. And finally, all of this just comes down to the ability for it to make decisions, which, again, is something we've always viewed as a solely human pursuit. Now, these are kinds of things that it can do in the abstract. You give it specific data, you train it in specific ways, and it can interact with different regimes. But the tools themselves are general, and they're usable in so many different cases. I think we can kind of sum this up in saying that, with previous technologies, whenever we've built it, there's been some sectors that they've changed. But AI can change the process by which sectors change, right? It's got the ability to drive this change itself, because it's kind of baked into our mechanisms for how we do this sort of innovation. Now, while we say all this, the role of AI is kind of on the fly as we speak is changing. Even before ChatGPT became a public thing, again, many of us were using AI. We'd call it machine learning, or we'd call it data science or statistics or something like that. But we'd have tools that would execute a command. Maybe you click on a few things on an interface, you fast forward a few years, you type some instructions to it, and it does a thing. It's executing your command. It's fairly safe to think of it as a tool. But we've kind of progressed, I think, particularly in the way many people use these tools now, into thinking of it more as an assistant, in that you're working collaboratively with, like, your AI in solving some problem. They could be preparing a talk like this. I would, for a talk like this, I would be going backwards and forwards on if certain parts of my arguments make sense, or if I'm highlighting the right things on a slide, right? That's the way you might engage with an assistant, someone who's sitting there by your side, guiding you through something, or you can offload small parts of it too. And then, as I mentioned earlier, with the kind of more move to agentic AI, we're starting to think of them more as kind of actors that have their own, to some extent, their own goals, are able to carry out work in multiple steps, are able to really make the kind of queries that we're requiring of them at the moment, and kind of outsourcing part of their work to other assistants, right? This has been, in fact, just over the last couple of years, an interesting shift in how we work with this technology, how we interact with it, and even how we refer to it. So if we think about what this means specifically for science, I think we're already seeing just this massive multiplicative power of this technology. And you don't need to go far to find this. You can kind of look at it anywhere. I mean, just quick Google searches will find that for the last couple of years, this has been a big discussion that people have been having more and more. And you get these kind of breakthroughs all the time that, like coding problems that AI has been able to help with. But beyond that, AI breakthrough finally cracked century-old physics problem, or speed up fusion energy development, or 600 times speed breakthrough in detection of signals from space, or unlocking new materials to replace lithium-ion batteries, better understanding things about kind of the genetics and so on around babies, and understanding genetically what's going on there, and even being able to fix things if there's problems. Looking at different kinds of medical conditions like male infertility, or designing new antibiotics for superbugs, or even tools that outperform all of our existing weather forecast tools. Now, these are things that are just, there's a slew of these things. And kind of every day I'm getting alerts of these things on my phone, right? In completely different areas, people are finding ways of kind of plugging in their disciplines, what they've been doing in different ways into these AIs, and able to accelerate what they're doing. And, you know, I think this is a super exciting time for science, because as we'll see, we can do things at a speed now that was never possible before. And in fact, could be done by, it's far more accessible, could be done by almost anyone with some kind of background knowledge, and a bit in the tools and a bit in the domain. But again, it's this kind of general purposeness that we're seeing, that it's able to make progress on all these different fronts. I think that's interesting in the scientific sense. We can even think more broadly about kind of invention and how we innovate, right? And again, it's this idea that it's not just changing what we're able to build, but the mechanisms, the kind of meta question of how we build things. And this comes in so many different ways. And I think we can just distill this down to a few concepts. You know, when you're trying to develop something new, whether it's, you know, in your research, whether it's a company, whether it's products, whatever it is, some aspect of this is a search problem, right? You've got to be able to look at multiple different candidate ideas. You've got to be able to eliminate some off the bat that they don't make sense. You've got to be able to prioritize. Maybe some of these are formulated by kind of combining, you know, things, coming up with analogs to other domains and so on, right? That's a big part of what we do, is the search procedure. And, you know, so many cases now we're able to see that these tools are able to help us do that, whether it's being able to scour literature for interesting ideas, whether it's being able to, you know, kind of list out things that that people are looking at, whether it's a better way to keep tabs on what you've been thinking about in your conversations with it, look at permutations of that and so on, right? This gives us a much more structured, but not in a limiting way, but a much more structured way to kind of explore the search space of the problems we're looking at. Kind of coupled to that is the ability to simulate things. And part of this is coding wise, but also part of it is able to kind of step through processes logically and say, you know, test ideas, you know, that kind of devil's advocate, or what would happen if I did this and this and this? What would the implications of that be? Now, many of these kinds of exercises are things that in some cases we do explicitly, many times we do implicitly. But here we can, you know, we've got tools that we're able to query implications. We're able to say, you know, ask the what ifs and so on. Now, yes, is this accurate? In many cases, no. If you're working in some kind of far out there kind of problem domain and you haven't given it any special information, obviously it's not going to do a good job, but it's able to help build the tools for you to do that. If you give it that information, it's able to read whatever kind of books you give it, whatever papers you give it, and kind of synthesize that in a way that can help you work through implications of ideas. Most importantly, it can iterate through all of this stuff, right? You can come up with an idea, question it, interrogate it, throw it away, move on to the next one, all within a very short space of time. And I'm talking about all of this just from the perspective of a single person sitting at a desk, right? This is all multiplied as well when you've got huge teams of people that are all engaging with this in different ways, all shaving off bits of time in different parts of their tasks. And finally, it's also able to implement things. Again, this could be through coding, this could be through very detailed instructions of how to execute things, whether they're, you know, we've seen now experiment design, we've seen things around surveys and so on, right? Something that's also able to guide you through best practices. Again, having awareness of kind of all of the knowledge that it's been trained on to build this thing, combined with your domain-specific knowledge, we're able to do all of these things quicker. And then just to layer on top of that, right, these are systems that learn, they get better as we use them. And as I say, the more kind of recent incarnations can also delegate what they're doing to other tools if you've set it up in such a way. Now, I'm going to provocatively say that AI will be humanity's last invention. I'm not the first one to come up with this. There's been a lot of discussion about this. In fact, some of these ideas go back to the 60s. But it's an idea that I think that I strongly believe in, and I think is something we need to take seriously. Now, this is often taken to mean that's because there won't be any humans around. But I think as benign as you can be about this, kind of building AI means other things aren't built just by humans alone. It's already a part of so many scientific processes. It's already a part of so many innovation cycles. And as AI improves, as we saw from some of those earlier graphs, that it is at quite a rate, more and more will it be in the driving seat of this kind of invention. And so I think we're past the point now where we are likely to see inventions coming out, like anything of any major import that was built entirely by humans. My bet would be that time is pretty much gone. I mean, if we think about this in the scientific sense, we're at a stage now where AI supports a lot of science, but more and more AI is conducting the science itself, and this ranges through a whole lot of different eras and a whole lot of different areas, and as we've been talking about, across a whole lot of different domains of science, right? This is in all the kind of obvious steps from like gathering literature, synthesizing it, figuring out kind of common threads to it, in formulating hypotheses or fine-tuning them and refining them, of doing things like experiment design, of formulating and improving models, of doing all your analysis, and of refining the entire process and iterating through it. I mean, there's now multiple cases of people having kind of instrumented their chemistry labs and so on, that they're basically being now run by various kinds of AI tools. Now, again, this is a thing that like we're not seeing. This isn't like a uniform uptake of things. I'm talking about, the examples I'm talking about are cases where we see this in the media, right? Which means they're still novel enough that people want to report on them. But I think it's happening at such a kind of scale and such a rate. And again, we have no reason to think that this is going to do anything but accelerate. So if that is the case, if what I've been saying to you is true, then, I mean, for this audience, I don't need to make the case for the importance of science and of research. We know how valuable this is. We know that governments around the world should be investing more into this, because that's like a way to kind of ensure a better future for your people and so on. That kind of power that's been encapsulated by science and innovation and engineering over the last couple of centuries, like, has really been the engine room of modern civilization, of life getting better for so many people. But this is becoming in kind of, from that perspective, synonymous with kind of power in the AI setting, right? If we think about kind of this AI capability, as that improves, right? And that's the models, the compute, the data, the tools, right? That's feeding into the scientific capability, right? As I've been showing you, more and more, this is already accelerating and will continue to accelerate what we're seeing in science, all right? Our discovery, our analysis, our design, these kinds of things. And again, that in turn leads to our strategic power, right? Our ability to set agendas, the way we think about our dependency versus our sovereignty and so on, right? So these kind of questions that have always been driven by science are now more and more going to be driven by AI. Now, if that's the case, then it's reasonable to ask, like, where are we in this picture, and who gets to shape that future that that AI is, the spinning motor that's just being connected up to the cogs of our scientific machinery. So who is able to shape this future? And this is where I'm going to move on to kind of talking about where Africa is. I mean, there's so many narratives about Africa behind in everything. Again, I think I'm talking to the right audience here that are aware that that's not the case. But if this is a bit out of your field, it's maybe worth thinking about kind of where is Africa? What are we currently doing in the AI space? Now, unsurprisingly, we've long been underrepresented. And I'm going to take one example here. The AI is an interesting field. It comes from kind of most closely academically from computer science, and computer science and AI then have this weird quirk that all of our publications are about conferences and not journals. All of our most prestigious ones. In fact, I always joke that it was silly of us to call them conferences because they're not like in other fields where you just submit an abstract here, they're double-blind peer-reviewed with rebuttal periods and all this kind of thing, but it obviously counts against us in many ways as computer scientists. We should have just called them interactive journals or something, would have been a smarter move. But anyway, the kind of most prestigious venue in kind of for publishing in AI is called NeurIPS, Neural Information Processing Systems, which is a huge annual conference that happens every December. And I mean, these days it's on the order of 15 to 20,000 attendees every year. It's one of the three major ones that are kind of scattered throughout the year, but this is kind of the longest running, biggest flagship conference. And, a group of us that have been working in the area, mainly based abroad, realized at some point, we started having this discussion in 2017, and we realized at that point that we couldn't find, there's an asterisk here, because it's not 100% sure of that, that there'd ever been an accepted paper in that conference from an African research institution, right? Which is pretty shocking that like from the most prestigious place in this field, this massive conference happening every year, okay, it wasn't quite so massive back in 2017, there'd never been an African institution represented there. Of course, many Africans, but ones that were working abroad. And what this meant is like, if all the discussions were happening at these kinds of events, that means as a continent, we were completely absent from kind of the global research conversation. And how are you supposed to stay on top of something if that's the way you're working? Now, of course, there were different sub-communities where people were better connected and so on, but just taking this as one metric. Now, this to this group of us discussing this was kind of a travesty and started raising alarm bells. Again, as someone who's been in this field for a long time and strongly believes in the power and the potential it has to change the world, and ideally change it for good, to see that my home, not just country, but continent, was largely absent in this way was really worrying. Because I was convinced this wasn't a talent issue. This was that there wasn't a community. Like what was happening was fragmented, right? There were scattered institutions and countries that were all competing, weakly connected, like no strong hubs of activity. I mean, small local things that were happening, completely underfunded and undersupported. And importantly, with the wrong incentives. I mean, this was, as I alluded to with the kind of conference versus journal paper thing, right? If you've got just the incentive structure set up not to get people going to the right places and doing the right kind of work, like that will never happen. And so again, just having been born and raised on the continent, having done my undergraduate studies here before I went abroad, I was convinced this wasn't a talent issue. And I was lucky that I have many colleagues that felt the same way. Because in 2017, a group of us, there were 8 of us who came together with the idea that we should do something about this and try and strengthen African machine learning. Now, at that point, we were 8 people, 8 South Africans who had all studied abroad or were currently working abroad. And we wanted to do something to give back. We thought, there's some of these business AI type conference things. But no, we believe in the talent and we've got to do something to help like accelerate it somehow. And we figured, okay, what we'll do is we'll organize kind of a week-long summer school. We obviously don't need money because there won't be many people interested. We'll just get the 8 of us to to give talks and that kind of thing. And we gave it a name. We called it the Deep Learning in Indaba. Deep learning was kind of all the rage at the time. We thought it was a nice, catchy name. And we thought, let's reach out kind of through our networks, through their networks and so on, find anyone who might be interested. We're thinking here, master's students, PhD students, academics, people in industry or anything like that are really interested in a deep technical workshop. And we kind of had this idea, maybe we'll find 30 people who would care for something like this. Right, here was the group of the 8 of us who started this all off. But this is what we wanted to do. And sure enough, we decided 2017, we were discussing this in January. We thought we got to do it this year, otherwise we'll never do it. So we had the event in September and we held this at WITS. So we held it at WITS and we had 330 attendees. And in fact, we had more than double that in interest of people who wanted to attend. And this was mind-blowing to us. This kind of changed everything. I mean, firstly, we kept getting emails from people saying, thank you so much for accepting me. This is the greatest thing that's ever happened to me. Unfortunately, a ticket to South Africa is 5 times my father's monthly salary. And we thought, oh, shit. And so we had to go and we did a whole lot of fundraising around this to pay for the flights. I think in the end, for about 60 students, we paid flights, accommodation, everyone's food, these kinds of things. And we being academics, we did like a double-blind peer review type thing for the accepting people. We tried to get a distribution. We had people from all over the continent. But there was such excitement around this that we thought we could do it again. And the next year, we went to Stellenbosch and had 550 people there. And then it's just been growing since then. 2019, we left South Africa for the first time. We went to Kenya, and we had about 700 people there, I think. We took a little bit of a COVID hiatus and then came back in Tunisia. I think we had about 600. We went to Ghana. We had about 800. Senegal, something similar. And last year in Rwanda, we had 1,300 people. So this is now the biggest machine learning or AI summer school in the world. And this year we'll be going to Lagos. So we've been kind of consciously moving around the continent. It's now organized by something like 80 volunteers from all over the continent. But it's been amazing just to see this massive growth, this explosion of people and passion and excitement. So what is this all about? I mean, we do the standard summer school type thing of intense lectures and kind of we pair it with practical sessions in labs. But we also, from the beginning, were quite conscious to add social events because we had this idea that we wanted a community. We wanted to bring people together and form some bonds. I think this is somewhere where our continent is not strong, and that's in individuals being connected to many people in many different countries. And we hoped we could do something with this. As I said, we made this free for students, and we paid for a lot of people to travel and so on. But since then, we've been innovating a lot and trying new ideas. So one of the first things we did is we had an Africa Research Day, which was encouraging all the students to bring and present posters. And this has become a strong theme of the conference. We quite soon started parallel tracks. So there'll be things for beginners in certain areas and more advanced people. There'll be sessions on policy versus technical and so on. We have deep dive workshops, which are now kind of organized and run by kind of sub-communities on the continent. We've always had things like women in machine learning events. We try and keep we work hard to make sure we've got a good kind of gender mix, like a good diversity of people around the continent. We even started doing things, we've experimented the last couple of years in some of the sessions, in fact, not even being in English, being in French and so on. And then we've had sessions on everything from ethics and policy and sessions for startups and to try and ideate new startups and then how to write papers and apply for PhDs and really kind of your one-stop shop for like just a super intense week that, every morning, like starts with people going for runs before breakfast and ends with events every evening and that kind of thing, right? Just trying to bring a community together. So with all of that, it was pretty clear to us that there was only so much we could do with one event a year. But fortunately, being somewhat slightly incompetent academics, we had some money left over after the first year. And we thought, what are we going to do with this? Maybe we can find a way to expand what we're doing. I know we'll run events in other countries. Wait, we're a bunch of South Africans. What do we know about running events in other countries? So we started a program called the Indaba X, where we could get people from other countries applying to us to host an event. They have to kind of meet our code of conduct and so on. There were certain requirements like partnering with the university at first and so on. And if there were multiple applications from the same country, we'd kind of send them back and say, figure out how to make it work at both venues or something like that. But we'd give them a little bit of money. We'd help them find speakers and advertise the event and so on. And so this was called the Deep Learning Indaba X. And last year, these ran in 47 African countries, which means that there's kind of these satellite events running all across the continent. These range from 30 people to 600 people over one day up to over 6 days. And then we've got mechanisms to make sure that some of the organizers and poster prize winners from each one get to attend the main event. So we've got this kind of continuous cycle of ideas and talent and people that are coming together from across the continent. So, this is a summer school. Okay, that's great. But like, what does this mean practically? Like, why am I making a fuss about this? I think it changed a lot of things. So firstly, something we saw after 2 or 3 years was there was a community that started called Masakane. And Masakane came out of a few researchers that were really interested in African natural language processing. This is this idea of how do we build these tools that can speak languages. I mean, mainly things like translation, transcription, and so on. But how do we do this in African languages? The challenge is they're under-resourced. So most of the standard machine learning paradigms are about if you throw more compute at something and more data at something, it gets better. But if you're in a kind of regime such as some of these, the 2,000 languages spoken in Africa that are under-resourced, where there isn't enough data, what do you do in that case? And this turned into a whole grassroots kind of community spanning the continent that started writing papers together. They started organizing workshops. They won awards from the Wikimedia Foundation. They've received a lot of money from kind of development funding and that kind of thing to be invested into building new language models. But interestingly, this is a community, again, that spanned the entire continent. You'd have papers with like 30 authors on them, everyone from different countries and so on. And this was really exciting and something we didn't anticipate at all. But then more happened. A couple of years later, Sisonke Biotic started as a similar kind of model doing AI and health. There was Roya, which does computer vision, like working with images and so on. And they've run already some massive kind of African computer vision summer schools with speakers from around the world that attend. And they've been doing this annually for the last couple of years. Recently, AfriClimate AI started. A good friend of mine, many of them are, but and here they've received a lot of money from various organizations to improve the kind of way that we're doing climate modeling in Africa. And this is everything from making sure we're getting better quality data so that we've got the right kind of models, because it turns out the big models that are working so well globally don't work as well in Africa. And then literally this last week, a new one launched, which is the Akili African Robotics Community, which I'm proud to say is many of my own current and former students that are driving this. And this is a kind of Pan-African movement around robotics, where the idea will be, again, to push kind of the cutting edge, come up with new ideas, tailor things to African solutions, and just make sure there's a community that can meet and share ideas and this sort of thing. And then looking beyond, many of the founders of the Indaba have been involved in helping other movements. So it was kind of this magical moment that people were saying, wow, this is crazy. There's a thing in Africa, but how do we get this in other places? And we helped launch Kipu in South America, the Eastern European Machine Learning Summer School, and the Southeast Asian Machine Learning Summer School. In fact, last week I was talking at a conference in the UK, and I was talking a bit about participation, and I mentioned this, and I had a bunch of European researchers coming up to me and saying, wow, I wish we could get this kind of passion from our own students. How do we get the same thing to happen in Western Europe? Which I thought was kind of cool, because it says that there's kind of a culture that can be pulled together, that can actually lead and change things and bring the right people together. So when we think a little bit more broadly about the impact, right, this has meant now that conference that I mentioned earlier on that had never had African participation. That year in 2018, my lab and another lab from South Africa had the first papers there, and subsequently there's papers there every year. There's a lot more kind of supervision going on, and many of us work with students from across the continent. There's jobs, there's a whole lot of new startups, there's opportunities for people to travel around, to study in different places. There's these kind of networks across the continent. Our network now is in the tens of thousands, but also really well connected internationally. One of the other programs I haven't spoken about was a mentorship program that, students could sign up for mentorship. And we've had hundreds of mentors from all over the world signing up to just be mentors. Many students that have gone all over the world for internships or to study and do these kinds of things, right? It's just, I felt like the African community was just welcomed into the global community with open arms. We've had new courses and programs starting up. I mean, at WITS, we've got probably 30 different modules we teach, but there's, courses like the African Masters in Machine Intelligence that runs through in Senegal and Rwanda. And there's all these interesting programs all over the continent now. And many of them have some connection to each other through the Indaba. And then importantly, there's been a lot more funding. So a lot of the development funding now has been increasing. People kind of see that there's interesting opportunities. They see that there's ways that they can invest in, programs. Again, it doesn't necessarily have to be the programs we've built, but we're helping to act as ways to connect people, that they can come and say, okay, we're interested in this country, investing in something around this kind of technology seems to be a good way of letting people build things themselves and lift themselves up. And in fact, we're even now starting to see more venture capitalists from around the world are happier to invest in African startups, for example, which again is good, because then you want to lower these barriers to people to do interesting things. Now, I think us participating in this way changes the field a lot, right? This isn't just a question of representation. This is about new questions that come up. I mentioned the African languages, but that's one of many examples. We deal with different kinds of challenges geographically, culturally, in terms of the way our societies are structured. We've got different philosophies, different influences. We've got constraints on our computing, on our data, our electricity, these kinds of things. And these are important to give rise to new methods, directions, and solutions. So participation is key. But there's one more question that's been bothering me. Like, does this actually shape the agenda? Right? It's one thing to say we're part of this community, we're at the table, but are we at the kiddies' table or the real table? And this is the last piece that I want to briefly talk about. Right? It's kind of the where to next. So I am kind of the firm belief that participation alone is not enough. It's absolutely essential, but we've got to go one step further. Right? When we have participation in this way, we've got visibility. There's people that are aware of what's going on. When they're aware of it, they can collaborate, they can invest, these kinds of things. We've got these networks happening, building stronger and stronger talent pipelines. And this momentum is growing. We see this in our numbers. Right? Maybe it's not quite the same exponential we're seeing with global AI, but this is a thing. But it doesn't guarantee things like the ability to kind of set an agenda, even locally. We're still very much tied to what happens globally, right? It doesn't mean we're thinking about kind of really the frontier questions. And I'll talk more about this now. We don't have anything that looks like institutional continuity. We're still very much at the whims of funders. And all of that means that like our kind of long-term sovereignty is shaky. Now, to me, sovereignty is an important thing. I'm not the kind of person who says, don't use foreign stuff. But I'm the kind of person that says, if we want to be realistic, how invested are we in certain things? Do we have an idea of how this works? Do we have the ability to replicate things? Are we dependent on someone who might, I don't know, set tariffs or disallow international use of technologies or something? Like, we've got to have some ability to stand on our own, but also in a space with so much opportunity. If we're sitting here with the kind of unemployment rates we have, if we're sitting here with kind of the challenges we have in our society, Surely we're missing out on opportunities if we're not connecting the dots properly here. And this to me talks to leadership. How do you make sure that you can take more of a leadership role in kind of something this fast-paced, something global, something that's really changing the dynamics of society as we watch? And I think it requires a few steps. One is the people. And this is like everything comes down to the people. But I think we're making amazing progress on that. We have incredible people. Like I keep getting asked why I don't go work in other places. And I keep saying, because no matter where I go in the world, I wouldn't have as great students and colleagues as I have here. And I really stand by that. We have something magical here, right? But you need more on top of that. You need institutions. And institutions are key. And we've done a good job as a country building institutions, but there's more we need. And I'll talk more about this in a second. We need infrastructure. We have a good amount of that in South Africa relative to the rest of Africa, but there's a lot more we need. But all of this then builds up to, we need research depth. You need to be leading in discussions and not just following, not just tagging on to what other people are doing, because that's about setting strategic direction. And that's where I think as a nation, as a country, as a continent, we need to stand up and start kind of proclaiming this. Like, we need to be leading in that strategic direction. So the institution question, I think, is big, because this is how we turn like the kind of raw talent into durable long-term capability. And it's through a few things, right? I think one is building critical mass. We all, no matter where you are kind of listening to this call, I'm pretty sure you're sitting at somewhere that's kind of under-resourced, everyone's overstretched in departments, this kind of thing. But we need to figure out ways of working around this, because amazing stuff happens when you've got critical mass. There's been a story of what we've been doing at WITS over the last decade, but we're sitting here with a huge kind of computer science cluster, which means we're able to do great things. I'll talk a little bit more about that. But your concentration, that critical mass, that gives you better use of resources. You can share resources. And most importantly, you can share and iterate on ideas faster. These connections are key, and those also happen and are facilitated through institutions. That means they're kind of longer term. You can connect between different disciplines, which is really key. You can connect between different agendas and partners and so on, and we'll come back to this. And finally, there's this notion of endurance, right? Projects and kind of ideas and the direction you set has to endure beyond individuals, but beyond individual projects, and beyond funding cycles or whoever's in charge of whatever funding agency you're working with. Otherwise, you can't build things that kind of stand the test of time and really make an impact. And interdisciplinarity is what's needed now in AI, right? Now, there's a misconception here that interdisciplinary in AI is like we take AI and we apply it to other things. And I think this is the wrong way to think about it. This is very much following trends. Now, we should definitely be doing this. We should be doing applied AI. There's so many low-hanging fruits, as we spoke about at the beginning of this talk. But I think really to set direction, we've got to do more than that, right? We've got to think more deeply that, at this point in time, everyone and their dog is doing AI. But generally, that means we're taking an off-the-shelf model and applying a local data set to it. And you'll never lead with that kind of mentality, right? To me, what's key is you need new questions, right? And when you bring different fields together, these expose fault lines, these expose problems. Like AI is built on so many assumptions, but we got to challenge some of those and think about things in different ways. Critically, we need to develop new methods. This is like at the heart of what I think of from the sovereignty question is we're going to be building new ideas. And this comes from drawing analogs from different disciplines and inspiration. In fact, the whole of AI came around like this, right? This came from inspiration from biology and neuroscience and how the brain works. And there's so many untapped ideas there that we could use and leverage and get better at. And I'm also really interested in this idea of like new definitions of intelligence. Like, what do we mean by intelligence? What do we mean by learning and reasoning? How do we think about adaptation? And particularly when they're applying to different segments of society and different sectors in different ways. I think there's so many opportunities to be broader about this and get that inspiration from other disciplines. So just to add on here, I've kind of alluded to this already, but I think as a country, we've got a special role to play. We've got a strong institutional base as a starting point. We've got a lot of interdisciplinary depth and a lot of potential to do this. Maybe we're not as good as we could be. I mean, academia is famously siloed, but there's so many opportunities here. And I would say some sort of continental responsibility. And I know many of us share this view that we've got a responsibility to our people, but to the whole continent. And I think it's these kind of values that we saw being so successful in the Indaba. And I think that's a bit of a super weapon to do amazing things. So with all of this in mind, there's a few things that I think this moment requires. And I would say kind of 5 pillars. One is to be thinking foundationally about AI. So again, this is the moving away from just thinking about applications of AI, but actually advancing it. Like, I want the next breakthroughs that become the next kind of billion-dollar companies to be coming out of this place. Like, that's what we should be aiming for. But those breakthroughs are the ones that change the world. I think they have to be interdisciplinary, because I think this is where we've got kind of an advantage. It's in many ways, I think, easier for us to be interdisciplinary than, say, some of the big American universities. And I think we've got possibly, this is a strength of smaller departments, but there's potential for this to happen. I think we have to stay African-centered and grounded in our priorities, because no one else is going to do that. We've got to think long horizon, because this is how you make sure that what you're building persists, and you can actually build momentum in your ideas, so that it's actually relevant and can live long enough to make a difference. And finally, we all know we've got to be doing capability building, but I think we're good on this front. So with these pillars in mind, I just want to give one example of what we've been trying to do at WITS with all these ideas that I've been mulling over the last couple of years. So just under a year and a half ago, we launched the Mind Institute, which is the Machine Intelligence and Neural Discovery Institute, and was very much driven by this way of thinking. And this was kind of a challenge, that I wanted this critical mass. I wanted the foundational work, and we've been doing a lot of this in computer science for about a decade now at WITS, but we needed to go bigger, and bigger could be hire more computer scientists, which, we'll totally do, but also think a bit more broadly. How do you take leadership roles, and how do you get around this critical mass thing? And the way we built the Institute is to bring together artificial and natural intelligence, right? We have so many amazing people that think about intelligence in so many ways, and this seemed such a key central point to build an institute around. I'm not saying this is the only way to do it. This is just an example, but I just want to show you how some of these abstract thoughts I've had have kind of led to what I'm working on at the moment, right? So this is really multidisciplinary, focused on the fundamental science of intelligence. And so we've brought together a critical mass of academics at this point. We've got 36 academics now. We're about to bring on a whole new cohort. About a third of them are AI and machine learning people. But then we've got people from every faculty at the university. So we have a lot of people in things like neuroanatomy and neuroscience. We've got neuro and behavioral psychology. We've got people that look at the future of work, that look at evolutionary studies. We've got ethicists and philosophers and so on. So really, anyone who's thinking about intelligence from different perspectives. In fact, there's governance people in here as well, right? All these things that kind of interlace and interface. How do we bring them together? And the way we've done this is to say people can apply to be these fellows of our institute. As I say, we've got 36 academics involved at this point. And then we bring them together. And it's my job directing this to get them to learn to speak a common language and get them to kind of have new crazy ideas. Because I think, if we're thinking about this kind of different intelligences, we're going to think about our questions differently, right? We're in different environments, so we should be thinking of different solutions. We've got different sciences, so maybe this can give us different ideas and models, maybe things that are more energy efficient or data efficient. And importantly, we have different societies. And I'm pretty convinced, there's a lot of issues around AI that I'm not talking about today. I'm very worried about a lot of the long-term societal impacts, and many people around the world are. And perhaps it's easier to find these solutions, if you look at it from an African lens, to find solutions that will be globally relevant, just because we've got different contexts. And so maybe if we're bringing different people together, convening different kinds of gatherings, different kinds of mixtures of societies and disciplines, we can solve problems that others are struggling to in a way that genuinely benefits the planet. So the way we kind of run Mind is we've got these fellows and we bring them together to come up with new ideas around intelligence. We basically have regular workshops on doing deep dives in topics ranging from AI safety through to consciousness or sleep. And so we bring people together to have these discussions across different disciplines. And we try and bring together new interdisciplinary collaborations by giving joint supervision or funding seed projects and things. And in fact, this is another thing I don't think we do enough in academia. My model for funding seed projects is it's got to be interdisciplinary, so you need people from different departments, but it's also got to be crazy. If a project fails in an academic sense, what does that mean? We learn some stuff, maybe we write a paper, maybe a student gets a degree. But if a crazy project turns out to do something interesting, that could shape everything, right? So we try and push new ideas, crazy ideas, while also building new generations of leaders and trying to set new agendas for the field in terms of thought leadership and so on. So, I mean, what I'm trying to say with all of this is, we think about what's happening in AI. To really lead in the space, we need these new kinds of structures. We need to think more dynamically. We need to bridge divides and silos that have really haunted us for ages, to take these new opportunities, to find new ways to do things, that'll let us do deeper research, because I really think the fundamentals are key here, to be more interdisciplinary and then more durable in the long term of what we're building. So kind of wrapping this all together now, right? I think the kind of three acts we've looked through here. One is, I don't think one can understate the impact AI is going to have on society, right? Because it's at that meta level where it's changing our procedures and in fact, and our processes. And in fact, now, there's more and more where it turns out the modern cutting edge AIs are being designed by the previous generations of AIs. And this is happening increasingly, which means, again, that's this kind of flywheel effect, that it's only going to get faster and only going to get more impactful and more accessible for people to take into different areas of society. And we've already shown that we can build that capability here. We've got to do more. We've got to be deliberate about this. But this is happening in Africa. But we really need to take it to the next level, that it's not just about participation. We've got to really go to agenda setting. We've really got to kind of pull ourselves up at the table, not in a charitable kind of way, not in a we can talk a big game kind of way, but in terms of that we are contributing the way anyone else anywhere else is. I mean, in this way, something I've been quite proud of is, look at similar institutes to what we've built at WITS, and there's ones at like Harvard and Columbia that are quite similar in their breadth, but none of them have wet labs in neuroanatomy, and none of them have evolutionary science, right? So we can build things that don't exist anywhere else. And in fact, we should, because if we don't have the same resources, we've got to be clever in how we bring them together. And we've got to be very deliberate in how we bring them together. So I think just to kind of wrap things up now, I think there's a few things we need to be doing as the South African research community, the science community. One, as always, we need to grow talent. But I think this is more than just reaching out to our students. I think we need to be doing what we can to attract talent to this country, whether it's bringing people back. We've already got some of these people that through the Indaba went to study abroad. Some are already starting to come back. But with the stakes being this high, we should be trying to attract anyone from anywhere. I keep joking that, there's various parts of the world that many academics are not happy, and keep nudging them and saying, hey, you want to come somewhere with democracy, right? We need to be doing what we can. We need to be working with the government to do what we can to bring all the talent here that can help really catalyze the next generation. We need to retain the talent and dramatically expand what we're doing. I really think if we could take a huge number of people in this country and equip them with the ability to do cool stuff with AI and show them how to do that, we could change the narrative of this country. We've got to be building these ecosystems. We've shown kind of through one or two small examples here on the value of it. But again, this is how you get around some of the resource shortages. You tap into the same kinds of networks. I think we have to be focusing on fundamental research. It's great to be doing the applications, and we need to do that. But we've also got to be setting trends. And we've also got to be doing things that could be playing, the multi-trillion-dollar long game. We've got to think globally. We've got to make sure, is everything we're doing competitive globally? Is it at the right level? Are we collaborating with the right people? We need to stop incentivizing that, someone is a solo author writing for the South African Journal of no one will ever read this, but instead going to the top places in the world, working with the top most famous people, whether that's publishing in conferences, whether that's doing stuff we haven't normally done as a scientific community. We've got to be dynamic. We've got to be agile, because that's the way this is all working. And finally, and I think critically, we've got to be strengthening our institutions. As I say, we've been trying to build new things, but that's not to say this is the correct way to do it. What we've been doing with Mind, we're partnering with many people. We want to partner. We want the strongest networks we can have, because this, to me, is a kind of almost existential question. We've got to all rally everything we've got to be able to solve kind of the challenges that are going ahead. And this is really time sensitive. Like we've got the next few years when I think there's still going to be a chance to get into this game, but we can't take a 20-year bet. We've got to build today. We're going to start building. So, with all of this, it's not going to be enough to just use intelligence. We've got to help shape it, and we've got to do this globally, and I strongly believe that we can. So with that, I want to thank you for listening to my rant.
Brilliant, brilliant. Thank you, Professor. Brilliant. Let me at this stage invite Professor Dane Brown. Dane, join me and offer scholarly reflection. Thank you.
Thank you for the introduction, Prof. Naidu. Wow, I was amazed by that presentation. I almost want to say that could serve as a planning document for AI, for South Africa's AI future. I'd go as far as to say that. There was a lot of things to unpack there. So I'm not going to go through everything because we are limited to time here, but I thought that there are some key points that I could reflect on, some of the things that directly affect me as well. But I think one of the big ones that Prof. Rosman talked about was AI as infrastructure. So sovereignty, meaning to shape it rather than to just consume it. That was a very big part of the talk. And I really think that this is really a key part of how we're going to build our infrastructure in AI around things like global assumptions of data and having things in such a way that we don't inherit constraints that we didn't even choose or notice because we perhaps used data that conforms to the global north. That's just one example. And I think that's one of the big things that popped up there. And that brought us to the point where Prof talked about where are we as Africa in the AI era. And to expand on that, before I talk about my reflection on my niche research, is that I think we have an opportunity to not just jump on the bandwagon here. So there's an AI bandwagon right now, if you haven't noticed. And we can't just jump on that bandwagon. We have to steer it, and we have to steer it on the African continent. We need to put on the right wheels, the right tires that can navigate that sort of terrain. It's not going to be easy. That's one thing I wanted to say. So as inspirational as the talk was, there's a lot of work to do here, and I agree, the work has to start now. It can't start in 10 or 20 years' time. We'll be too late if we start that late. So stuff that can be solved in the local context that I can maybe provide some reflections on. So I've worked with SIAB and SANBI and a bunch of other acronyms, FABI, so the Forestry of Agricultural Biodiversity Institute. And one of the big things that came out of that was that we need to be able to create our own local models, right? Our own local machine learning models that can more accurately detect things like plant diseases. Now, the wheat mosaic virus is something that we're in danger of devastating our yields or our crop growth in South Africa. And one of the projects that we worked on was to create a system that can do this early. So doing early disease detection is important because once we detect disease, or once we can see disease with our eyes, it almost means that it's already too late for the farm. So that's very important for something like our food security in South Africa. And if I ever wanted to use an exemplar for solving a local problem, I think that would be a major one. Now, what I also think is that locally grounded research isn't a compromise in this case. So we found that tailoring the models to be local and to make our own breakthroughs didn't compromise on rigor, but it was actually a requirement for it in this case. So that's one of my reflections on the research side of things. Funnily enough, one of the bigger reflections are actually on the teaching side of things that I want to bring up here. So now teaching AI starts before the computer. That's what we um, realize, that using if we have to lecture students and we have to rely on the computer from day one, we almost already setting ourselves up for trouble here. And it's a very strong statement that I make, but the reason for that is that students often first have to learn how to use the computer itself, and teaching them how to solve very, very complex problems so that they can eventually become AI engineers, etc. We often first have to start with the foundation, and that sort of foundation is what we've been teaching in first year this year, where we find that offline programming and doing things on paper, doing our traditional problem solving, makes a massive difference, because students suddenly don't have to learn multiple things at the same time, which is computer literacy, and there's some numeracy issues as well that have been popping up. Now, we decided to front load a lot of our courses with problem solving and unplugged activities, like I said, and we found that it worked incredibly well. As much as AI is amazing and it's a bandwagon worth jumping on and steering, like I said, there are also problems, right? Practical tests have to be brought in and invigilated. So that's all extra capacity, that's extra time taken from lecturers and TAs, etc. Because if we don't do that, students tend to use or abuse AI, and that can be a problem. So we found that this worked incredibly well, using prac tests, to such a point that students we're not going to ban students from using AI, right? Because I don't think that's the right approach. We need to jump on the wagon, but we also need to show them how to use it correctly. So the practical is now dedicated to showing them how to program, whether that's using AI as a way to help plan to solve problems or not. That's entirely up to the student, but it's part of how we tutor and lecture students now during practicals. And the prac test is just the cherry on top that helps for us to summatively evaluate students on whether they're making progress. But now, how do we as an academic cope with all this extra workload? Because you can imagine it's not just computer science lecturers like myself and Prof. Rosman, but all kinds of disciplines, right? And I increasingly find that I use AI as a personal assistant. So it's my PA now, like, and it works incredibly well, because as you saw in those graphs as well, it's solving more and more complex problems as we go along. And we need to really use that to our advantage. So it's all well and good to identify that students are now using AI or misusing AI in ways, because it's solving almost all the problems for them that they ought to learn, right? They ought to understand. But we can also use AI to our advantage, and that's something that I wanted to bring up. Something that I really liked and I thought was amazing, I thought I just should at least mention this, was the deep learning in Daba, because some of my students also attended that, and thanks so much for that, by the way. It's amazing. It helps you with networking. It helps you with so many different things. I mean, because at the end of the day, what are we doing here? We're trying to solve problems, but it's crucial to realize that algorithms don't do the problem solving. People do. So we need to upskill people, especially in Africa and South Africa. Some other biggest wins that we talked about, or that we saw in the presentation, was that the biggest wins are actually at the disciplinary boundaries, and I've found myself in that shoes more and more, especially this year, leading a lot of university-wide projects that are AI-based rather than faculty-wide or department-wide projects, and I found that quite interesting. It just happened, right? You're at the forefront of things, and things like that just happened, and it's quite an exciting time to be around here in the AI space. A very powerful statement that was mentioned was that AI will be humanity's last invention. This alone, I just thought I'd mention that this alone will raise up a lot of, you could call it controversy as well, but a lot of things around universities, especially around humanities. For example, what will movies and music look like in 10 years' time? What are actors and musicians going to do? What will their role be? I still think they'll have a role, but what will their role be, right? That's just one small thing off the top of my head that I can think of that will be affected over here. Very interesting conversation starters for later. And then, yeah, AI is a strategic and scientific discipline, right? So I agree that the greatest contributions to South Africa will come at the edges. So it's not just about this collaboration now that's university-wide. It also involves collaboration across different South African universities. That's key. And then lastly, I just wanted to say that Prof. Rosman asked what it means for South Africa and Africa. So what does all of this mean? From the lecture hall to everyday tasks, I believe that we're already shaping AI in some ways, not to the level that I would like it to be. I would say that we're not too late to jump on the bandwagon and steer it yet, but we shouldn't delay anymore because we are reaching that point now where we are underrepresented, we're under-resourced, but we have great potential. So the time to strike is now. Strike while the iron is hot. And to close, I would say that the major task now is to build the structures that enable this to let that purpose scale. So thank you for all of that. Thank you for your time. And over to you, Prof. Naidu.
Thank you, Prof. Brown. Thank you very much. Colleagues, it's now time for us to go into question and answers and take a discussion with Prof. Bosman. I have a few questions that the delegates have posted on the chat, so I'll serve and assist in sharing those questions with you, Prof. Bosman. In terms of the role of ASAF, how can we help you shape the national and continental agenda going forward from the Academy of Science?
Great, thanks. So I think it's tough, and I think that there's a few aspects to this, and one, I think, it comes back to, can we be very rapidly building our critical mass and doing it at different levels? So the levels range from, at the university level, to kind of touch on some of the things Prof. Brown mentioned. There's a lot going on, that affects everything from teaching to our research. And I think we've got to kind of change the way we're thinking about a lot of this. One is, AI is a bit of the great global disruptor that's affecting every single industry. But it's also, when else in your life before could you get a free or like a $20 a month PA and lawyer and, whatever other assistance you needed? So everyone should be using this, and we need to be training people to use this. If you've got your students, I think to some of the points there, can we be instead thinking about, they should early on be, we always want to teach them curiosity. Can you teach them to be curious by saying, anytime they ask you something, say, what did your AI say when you asked it? And, that kind of thing. So we've got to, I think, start from the groundswell there. I think it's important to remember this isn't just a computer science question. When we look at, there's a whole lot of issues around like the ethics and the potential societal impact. And I often say that the problem is there's two groups of people that think about these questions. One, either they're people like ethicists or sociologists who have no idea how the technology works, so they don't know what to be worried about, or they're computer scientists that have no idea how society works, and so they have no idea, again, what they should be worried about. And so this is kind of at its core an interdisciplinary kind of question. I think, we need to be lowering barriers between kind of conversations. We need to be making it easier for people to do things. And we need to treat this as almost as an emergency. I think, again, if we come at this from any angle, one, we can look kind of future thinking. I honestly feel the next 10 years are going to be the most disruptive in human history because of AI. And I think it's all going to come down to how well prepared are we. We're going to see huge layoffs across the world in different sectors. Now, if we've positioned ourselves well, we could say, well, that's a relief. All those people don't have to do terrible work anymore because we built the right structures very quickly. Or it will be terrible and there'll be, continuous rioting and potential societal collapse. It's these kind of things that come down to how well prepared are we. So we've got to be agile. We've got to be able to move quickly. I think we need to not spend a lot of effort, like, just building things for the sake of building things or ticking boxes, but really trying to rally people, say, okay, how do we all best engage in this conversation? So like even what we've been trying to do, there's so many talented people. Again, you might have a limited pool of, say, your computer scientists, but if you can get a whole lot of people in other disciplines to have the right tools at their fingertips, they can do a lot. But then we can even take it further. We could say, we know there's a lot of dragging feet and various things at the government level. Can we be looking at improving anything from bureaucracy to service delivery that has an effect of adding friction to these systems? We should be able to do a lot quite quickly if there's the right people in place. I feel very strongly we should be trying to act as an attractor for foreign talent, because there's never been a more important time. But we've still got, the countless visa issues. Like all of these are things where if we could just move the needle a little bit and make it a slightly more kind of welcoming climate and climate that fosters more innovation. I also think this is the only way we deal with our massive unemployment is, if we can go to anyone, we know that a ton of the people that are not in good positions in this country are still very smart people. And if you gave them this kind of technology for basically free, they could do amazing things with it if they were instructed in the right way. I think the potential is huge and the potential for disaster is huge. And basically just standing in one place leads us towards disaster. So we've got to reduce the cycles of like trying things. There's this, one thing I love about being a computer scientist is the mindset of rapid innovation. Try stuff, see what happens, throw away what doesn't work and try the next thing. And I think we need to embrace that more at an almost systemic level.
No, excellent, excellent. Now, concur with that. And I think as a SAF, we must help you raise the flag on a national emergency, and we must call for an enabling and friendly environment so that this whole technology can thrive and prosper. No, definitely will support that, Prof.
Wonderful.
Let me continue with the questions. Prof, over time, society has moved from the early Iron Age through the agricultural society, the industrial society, and we're now in the post-industrial society. And again, along the way, we've built inequalities, and we've now assembled this sort of inequality in our own society, particularly deep in the case of South Africa and then rest of continental Africa as compared to the global community. Now, how can we take this technology and help us to level out the playing field for all going forward?
I love that question. I think we're certainly in a world now where there's, probably a lot more goodwill to try and like solve these problems than we've ever had before. But, they persist because, among many things, we don't have magic wands to solve problems. But the kinds of things that come up, and there's, just to pick whatever examples come to mind here, we've got issues around, food distribution, for example, and these are things that are largely logistics problems, which is, stuff that we've got technology to solve. A lot of the problems we have come from things like corruption. And again, we should be able to use technology to solve this. Now, that to me doesn't get to the core of the issue. And I think we are going to see this. This is another thing I can say that often gets me in hot water. But I think the whole thing that we're going to see about the future of work is going to be super interesting. Work, the kind of way that humanity has run for thousands of years is all humans need to find a way to be useful. And like there's work that needs to be done. Starting off with because people need to eat, but these days because companies have to be kept afloat and so on. We've all got to do work and then we get a paycheck. And to some extent, I've always found the system quite immoral because most people on the planet do things that are bad for them, like psychologically or emotionally or physically. Probably the people in this call like their jobs. No matter how much you like your job, you don't like everything about the job. But to some extent, it's still tied to your ability to feed your family at the end of the month. Like you've got to do this thing. Now, it occurs to me if we're serious about what AI is going on about, and if you listen to all the kind of CEOs of the big tech companies, and the narrative is very much to build AI that can do every single thing a human can do better than a human can do it. Now, regardless of what you think of that, if that's the stated aim, and that's certainly what people are throwing all the money at, how do we turn this on its head and say, okay, let's say, that we could even automate some percentage of human jobs away. Let's say X% of human jobs get automated away. And it's, I think, just based on what we've seen with the technology over the last few years, I think it's hard to question that. Like, I believe that X is 100, but I think everybody believes there's some percentage of jobs that can be automated. Now, again, like, are these things where we want to like upskill these people? And this was always the narrative we use. But to some extent, again, if we're trying to build general purpose technology that's better than people and cheaper than people and more capable than people, surely at some point we run out of jobs. Like, is there a law of the universe that says we'll always have enough jobs for people? Well, in South Africa, we realized there isn't a law of the universe. So is this not our opportunity to say, okay, can we kind of figure things out differently? If we've got things that can produce more than we've ever been able to produce in human history, and we need fewer people working than ever in human history, that means there's two things we've got to figure out. One is, how do we distribute value to all those people that aren't directly involved in producing that value? And there's an interesting economics question. I'm not an economist. I think there's that whole thing that starts with UBI, but there's all sorts of interesting ideas there. And then there's the question of value, where people tie their identity to what they do for a living, which again is very interesting, but I don't think it's necessary. In fact, I recently discovered apparently when you retire, you can take courses on how to find value in your life, not having a job, which means that it's possible. So if we solve these two problems, we should be able to work around this. Now, maybe this sounds like fanciful utopian thinking, but I feel like if we don't start thinking this way, we're going to wake up one morning and they're going to say X million accountants no longer have jobs and are unemployable and all their families are going to starve and there's nothing we can do about it, or X million drivers or this or that. And I think we're going to be up against that fight forever unless we can say, okay, can we reframe this entire conversation to say maybe we should be liberating people sector by sector from jobs and celebrating this, but we've got to build the right structures so that they don't fall through the cracks.
Right. No, thank you for that. Thank you for that. Prof, your thoughts on AI and ethics?
Right. I mean, I think there's a lot to say here as well, but maybe I'll try to keep some answers short now. I think there's interesting opportunities here because, and particularly in Africa, we like a cool thing like being South African is we've all kind of grown up in a society that's, very multicultural, that there's a lot of like almost competing tensions that come in very different ways from like language and culture and background and heritage and things. And we find a way to make society work. Not perfectly, but we do it. And I think that's an interesting example of how we as a society have kind of found our rules for working together. And I think this happens differently in different parts of the world. Now, there's a lot of work at the moment in AI on trying to build, safer, more ethical AI. I don't like the way it's usually done, which is like we build the AI and then we figure out the band-aids on top of it to make it behave nicely. I think it's got to be built from the ground up, which is, again, one of the reasons I'm so interested in the foundational work. But I think when you kind of think about the way this works, there was an interesting experiment a number of years ago from MIT called the moral machine. Now, I don't know if you're familiar with the trolley problem from philosophy, where they say, the train is going down the tracks and there's 5 people tied to the track. You can pull the lever and change it to the other track, and then it will hit one person instead, right? These kind of problems. So there was this kind of experiment which was very interesting, where they had scenarios, like it was on a web app, it might even still be running, where they'd be like, okay, in this case, the car could go this way and crash, or go that way and crash. But in case 1, there'd be a granny, 2 cats, and a bank robber would die. And in case 2, there would be a baby, a high net worth individual, and someone who's about to die, of old age or whatever. It would give you these weird scenarios, and you do lots of these. And then they ended up, what was interesting, coming out with the statistics of what was prioritized in different parts of the world. And like, there were interesting things, like I think in Japan, there was a cultural trend to protect the elderly. And in the UK, it was like the fitter individuals. And in Nigeria, it was the wealthier individual. It was super interesting that these trends exist. Now, if you've got like one place in the world that's developing your AI and putting in your ethics and values into this, we know it's not going to have in fact, the same people in the same place aren't going to have the same values. So not even saying what are our values, is the right question to ask. I think we're in an interesting position to say, how do we build the system that can negotiate between a whole lot of different value systems? I think that's a super interesting question, and the kind of thing where I think almost we've got a leg up. It's the kind of thing we've implicitly been dealing with as a society for a long time. So I think there's so many exciting opportunities where we could have better solutions coming from here just because of the backgrounds we have.
Agreed. No, fully agree. Fully agree. Prof, there's an administrative question from one of the delegates. Your Mind Institute, are the academics engaged full-time or part-time?
So they're part-time. And in fact, it was very purposefully done like this. What I would have loved to do is just employ a whole lot of people and bring them together. But the two important things to me is, one, it was building the critical mass. That's getting a lot of people working together. But secondly is, if we're already resource constrained, it's counterproductive to pull people out of their departments. And so what we've done is, this is an affiliation. It's not even at this point a paid affiliation, much as I would love it to be ultimately, but we're trying to be lean and pragmatic. In the same way as I refused to launch this until we had fellows who were actually working on research projects. So the idea is that our fellows, this is an additional thing that's in their time. Now, nobody's got extra time, but we say, look, you've got research time. This is meant to amplify whatever's happening in your research time. So, when we have our workshops, people always say, wow, that feels like I was at a conference and I had these fascinating discussions. It was so much fun and enjoyable, and I'm excited about these projects. And so it's about trying to figure out a thing that works for the people in it and actually motivates them. And, part of the question for me is, when we build institutes, it's or these kind of big national programs, the question is, how do we get 20 PhDs through a thing? And that's an important thing to do. But I was wondering more, if I've got a bunch of amazing academics, how do we push them to the next level where they're all getting science and nature papers, right? And to me, that means you've got to be encouraging each other. You've got to have the right culture. You've got to be asking bigger questions, more inspiring things, bringing each other on as collaborators. With my research lab, there's two golden rules that I have, and I've tried to bring that into mind as well. The first is always work on the coolest thing you possibly can with the coolest people you can find. And if you're not doing that, then what are you doing with your time? But secondly, that credit is not a finite resource. So there's no harm in having extra collaborators. If someone helps out, they get their name on your paper, awesome. The more the merrier. And I think with these kinds of things, we always just try and build an environment that people want to be in. And even if they're not getting anything financially, there's some prestige involved, but also just this is why they signed up to be academics, because they want to think about cool things and have these discussions. And then, the cool effect of that is I'll wander around campus and go to a coffee shop, and there'll be a colleague of mine from computer science talking to a colleague from geosciences, talking to a colleague from philosophy, talking to a colleague from psychology, and they're having some interesting discussion on something AI related. And that to me is the kind of sign of success, that you've got that critical mass starting to happen.
No, first class, first class. Thank you, Prof. And thank you for an excellent presentation, and thank you for the work that you are doing at the University of Witwatersrand. I once had a meeting with the vice president of Google, and I had remarked to him, I said, you must bring all your investments to Africa, and we'll accommodate you at Victoria Falls. You could have all the energy at Victoria Falls, water and electricity, and we can let the technology do the work while we go play with the animals. So I think man's got to go back to Mother Nature. Man's got to spend time with Mother Nature.
Exactly.
Let me at this stage invite Professor Himla Sudel. Prof, join us and deliver the vote of thanks. Over to you, Prof.
Thank you, Pat. Benjamin, what a fascinating presentation. I must say, I've been a fan of yours for a number of years. My nephew is a mechanical engineer, was very keen to come and study with you. And through him, I heard about you, and I've been following you and your progress, and I want to congratulate you on all of your achievements. I must say, having seen some of your work, I came in here today thinking you're going to give us like a real hardcore technical kind of presentation, where the way in which you have embraced the technology to advance a particular type of interest that you may have. But I must say you have done justice to what we had as a vision for the STEMI lecture. You have given us such a breadth of wisdom from your collective experience, in which you posed those three questions and more than adequately brought your vision in a very unstinting way, in ways in which we can use tools to advance science, and in particular science, technology, and innovation, which is the big ethos of our current Department of Science, Technology, and Innovation. And you've done it with so much of suave, because you're very much people-centric. And the way in which you answered the questions reiterated my thinking and perception of you, that for you, success is seeing it in others rather than yourself, and building that network to bring about the change towards seeing the light at the end of the tunnel, which is infinite. I also like the way in which you positioned AI as a tool of being there to change the future. And you brought it into context in many ways that should be extrapolated to other visionary disciplines as well. Because very quickly, as specialists become myopic in our vision, trying to build the ego of where we want to go. But what you brought and shared with us is where we can go if we take the tools and do it better from the experiences of others. And I think that is quite a remarkable trait. And I'm sure those people who have been following the lecture must have taken a lot of notes, as I have done, to reinforce the ideas in my brain. But I also want to say that the STEMI lecture is actually the brainchild of my colleague Rajeshri Mahabir. As you know, she's a program officer for STEMI and for the humanities. And she, working together with the standing committee, the STEMI standing committee, have been working hard to try to find us a speaker. And I think they have done remarkably well. And I want to extend my heartiest thanks to them, to Raj in particular, and her superior or manager, Dr. Malusi Twala. We had Professor Rolnick on board, etc. And even Pat, our program director. I mean, you want him to teach you about energy and water resources. He gave me a crash course in the foyer of one of the hotels before a meeting as to how alternate energy should be used in the country. And so I'm going to pick his brain at a later stage to do something for us during June or July, when we take it out into community engagement of science. So many people work behind the scenes, and Benjamin, for your benefit, Asaf has started an AI forum. I'm sure they would have talked to you to try to pull you on board, but I mean, I realize that your hands are full, but somebody asked a question to you about what the academy can do. And we do not want to usurp the portfolios of the active researchers in the field. But if every now and again you can just give us the nod to help guide, because the job of the academy is to bring together the various activities and try to glue it. I think you have done remarkably already in this regard. But there are other centers, as you know, and I've been looking at the participants on, this webinar, and there are many from other realms who are not here today, but this recording will be posted for people who could not make it so that they could hear it. So without taking up too much of time, I just want to extend heartfelt thanks also from the ASAF president, Professor Majosi, who unfortunately could not be here today. And I met him on Friday, and he also had a lot of good things to say about you and your work ethic, etc. So from all the council members and ASAF who are not here, and the staff at the Academy, I want to really thank you for sharing your time, for sharing your wisdom. And I wish you every success in your fight ahead. My question to you would have been what would be your doomsday prediction for AI? But you don't have to answer it. Maybe we'll chat by email at some point, because it's time's up and I know people have things to do. So with that, I want to thank even our SciAS colleague, Professor Brown, for sharing his insights with us, and everyone within the Secretariat and the Standing Committee for making this lecture possible. And with that, Pat, over to you. And thank you also for all the support that you give us at ASAF. All the best, colleagues. Have a good way. And back to you, Pat.
Thank you. Thank you, Prof. Thank you. And let us also say thank you to our delegates who participated and attended the webinar of today. Much appreciated. You will get a full set of the recording and together with the presentations. So let us say goodbye from the Academy of Science till we meet again. Thank you very much and bye-bye.